Good morning, everyone. In today's video, we're going to discuss about runtime environment and code generation. In the last video, what we have discussed, what are the issues of code generator and how to calculate how to write a code for code generation as a target program and how to calculate the cost for the target program we have discussed. In this session we're going to discuss about, in this fifth unit we're going to discuss about runtime environment and code generation. The runtime environment is a state of target machine which will be having the variables and environment and process of running system, how the package was, how the executable program, how it will execute fast, how the communication is done in the runtime environment, how the memory location, deallocation, allocation is executed. So these are the things under the runtime environment. In the symbol table, in the sense how the data structures stores, the compiler stores the name of the symbol and what is the counter value and what are the changes occurs in that and new information whether it's updated or not in the symbol table. That is about symbol table. And next one is storage allocation information, how the storage allocation is done for the symbol table. Each and every time how the assembly code and assembler, the storage values, names and the compiler generated definition up and apply that assembly code and that allocation, how that is done, where the storage is done. No storage allocation is done for names whose storage is allocated at runtime. Like that, we have a different storage allocation information. The storage, in the sense, we have split it into five. First one is code. Next one is static data. Next is stack. Next one is free space. Next one is heap. So here the local address space in the for the each program, the location is, first one is memory location where the code, next one is static data. The static can also be determined at compile time. Then one is stack allocated at runtime. Next one is free space. Next one is heap, that is heap is other dynamical allocated object at runtime. For example, MLF, memory allocation area in C. The runtime storage blocks have the mission word multi-byte objects, and its compiler may allocate 12 bytes and enough to be 10 characters. Size of some program object runtime may be placed in the area called static, the dynamic area used to maximize the utilization of space at runtime, or stack and heap. The activation record, there is a seven split up. First one is return value, actual parameter, control link, access link, saved mission status, local data, and temporary. These are the different values. What is return value is calling procedure. Actual parameter is the parameter to be called for the procedure. Control link is the activation record for the caller. Access link is the non-local data for activation record. Saved mission status is the status of the mission before procedure is called. Local data is nothing but the local execution of the procedure. Temporaries is nothing but the evolution of expression, some temporary values. These are the seven fields in that activation tree. Activation tree, how to draw activation tree for the given program is sequentially manner how the procedure is executed. That is in the form of tree structure, is called as the procedure, is called as activation tree. The activation tree have some control flow where the representation activation record is passing through, that it is like a tree structure. For example, if for this program they have done an activation tree, printf, first it will execute, then it will go to scanf, then it will call the value, then it will go to the show data function. In the show data function, it will process print, finally it will return the value, then it will go back. So this is a tree activation record for the given program. Next one is stack allocation space. How the stack is allocated is, first it will lay out the storage for the compile time and runtime storage track. Heap allocation and deallocation is done at runtime for heap, and storage allocation strategy used in distinct part of runtime memory. Now we're going to discuss about how the activation record, what are the different strategy purpose in old foot and how they used, and this language how they have done, algorithm how they have done the storage allocation system. Static allocation is done, static allocation space, and activation tree with one example we're going to discuss. First one is given example for stack allocation space, that is static allocation spaces. The name and home to the storage program that is compiled. No need for runtime support of package. Run every time a procedure is activated, its name and then bounding is done in the same storage location. Okay, static allocation spaces, we'll use the last in first out allocation support for this regression process. We are calling sequence wise. this is the caller's responsibility. This is the caller's responsibility. This is caller's activation record. This is caller's these are the parameter what we have discussed, the divisions of caller and callee function. And this is the activation tree we have done previously for small program. This is the activation tree for quick sort. Quick sort, we have some pivot value. The pivot value is split into two different, one is less than value and another one is greater than value. And finally we are again and again we'll split using the pivot value. We'll segregate that quick sort. So that is a concept here. For that we have done an activation record. So finally, that heap allocation is nothing but the stack allocation strategy used the following. The value of local names must be retained when activation ends. A called outlives that caller. Heap allocation parcel out pieces of contiguous storage. Need of activation record or other objects. The activation record of procedures R is retained when the activation ends. For example, they have done this activation tree for the quick sort. What is a control link and what is a remark? Whether the activation record is processed or not, whether the value is computed or not, it cannot be formed or can be formed. The quick sort is will get the value or not. Based the flow of that activation record, we can identify how it executes the procedure. So in this today's session, what we have discussed is what are the different storage allocation and with one example of activation record. So I hope you understand the activation record for the quick sort. We'll see in the next session. Thank you.